Hi everyone, I'm Mr. Fullerton, and today I want to take just a few minutes to talk to you about the wave phenomenon, resonance. Our objectives are going to be to define the term resonance and also to show some examples of resonance, some applications where you might see it used. Now, certain devices create strong waves at a specific natural frequency. And typically, we're going to talk about resonance in terms of sound waves. It does apply to other types of waves, but usually we're talking about sound. If another object having the same natural frequency as this first object begins to vibrate when it's struck by these sound waves at the same frequency, it vibrates at this natural frequency. In the process of the first object vibrating, creating waves that cause the second object to vibrate is known as resonance. A very popular example is the opera singer, someone who can break a glass by singing a very high-pitched note very loudly. And there's actually a famous commercial where Ella Fitzgerald does this. She sings very loudly and it shatters a glass. And the commercial is all about the fact that they recorded her voice on Memorex audio tape, and by playing back the tape they could shatter the glass. Now the glass resonates or vibrates at the same frequency that singer emits the sound at. So the singer has to have perfect pitch and hit just that frequency that causes the object to vibrate. And as it resonates, as it moves faster and faster, the vibrations in that object eventually are too much. It stresses the object and it shatters. That's a great example, or a popular example, of resonance. It's kind of tough to show that here in a video lecture. Even if I had two tuning forks of the same frequency, and I struck one tuning fork over here and caused the second one to vibrate over here, really can't show that because we don't have the sound capabilities here just over the computer. But what we do have is MIT Tech TV made a great video showing this effect, breaking glass with sound. For those of you watching this on the APlusPhysics website, if you click on the video itself, it should take you to this link. For those of you watching on YouTube or somewhere else where we don't have all the same capabilities, this link at the very bottom should take you to this excellent demonstration of resonance. So, let's look at a couple sample problems. Number 1, sound waves strike a glass and cause it to shatter. This phenomenon illustrates, well, very obvious, this is an example of resonance, number 1. Or 2, a dampened fingertip rubbed around the rim of a crystal glass causes the glass to vibrate and produce a musical note. This effect is due to, well, once again, of course, this must be resonance. Number 3, resonance occurs when one vibrating object transfers energy to a second object, causing it to vibrate. The energy transfer is most efficient when, compared to the first object, the second object has the same natural frequency, loudness, amplitude, or speed. You get the most efficient energy transfer when it vibrates at the object's natural frequency. Answer 1. And one last problem. A car traveling at 70 kilometers per hour accelerates to pass another car. When the car reaches a speed of 90 kilometers per hour, the driver hears the glove compartment doors start to vibrate. I think I owned this car at one point. By the time the speed of the car is 100 kilometers per hour, however, the glove compartment door has stopped vibrating. This vibrating phenomenon is an example of, well, this is another example of resonance, of course. As the car is moving faster, it vibrates with a specific frequency, and at some point it hits the natural frequency of that glove compartment, which causes it to vibrate. Now, as the car goes faster to 100 kilometers per hour, its vibrating frequency changes, must increase a little bit. It passes the vibrating frequency of the glove compartment, and the glove compartment no longer vibrates with that same frequency. So there's only a specific set of frequencies at which this effect works. Hopefully this gives you a brief introduction idea of what resonance is. There's a lot more you can go into, but for introductions, overviews, hopefully this gets you started. If you're looking for more information, need more help, visit APlusPhysics.com. Thanks, and make it a great day.